Well, hello guys. In the previous video, we marked question 10.5 from question 10 in this consolidation material. There you can see the question answer. But question 10.5 have two options. One of them were using the law of conservation of energy, which we did explain in that specific video. I'll leave the link here if you want to see it. But I said in the next video we're going to do the same question using the work energy theorem. Now let's go back to the free body diagram. Let's redo it here. Remember, it's when the block is in the ground. So you have gravitational force and you have frictional force pointing up. Alright, this is the two forces acting. The displacement will be straight down. This one is because we need the angles. This is the displacement. Alright, so those are the two forces, and we're starting with the work energy theorem. We have to say that the net work is equal to the change in kinetic energy. This one is the work energy theorem starting point. Now the net work is the work done by each of the forces, the addition of each of them. So this one is the work done by gravitational force, which was calculated already, plus the work done by friction, and this one is equal to half mass final speed square minus half mass initial speed square. This one is using the work energy theorem. Okay, so note the following. The work done by gravitational force that we did calculate it is not going to be used, guys, because this one was for the entire motion from starting point to end point. We are not going to use this one because now the one we're using is from the time that the stake is in the ground for that 0.2 meters only. So we have to recalculate the work done by gravitational force, but not to worry, it's really easy. So we can substitute the formula here. Work done by gravitational force is equal to the product of gravitational force multiplied by the displacement multiplied by the cosine of 0 degree. Remember, the free body diagram is for you to see the angles here. Okay, plus work done by friction is equal to friction multiplied by the displacement multiplied by the cosine of 180 degree. You come here, the angle is going to be, as you can see here, 180 degrees. All right, so this one is equal to half the product of mass final speed square minus half mass initial speed square. All right, so we move on. We can now substitute everything, but remember, gravitational force is mass times acceleration, which is what I'm going to substitute in there. When you do this calculation, which is quite simple calculation, you get that is 11,771.27, the same as if you use the other method. So this one was done for these learners that maybe like to use the work energy theorem. Mark allocation, more or less the same. There is one mark for this part. Now when I say this part, it doesn't mean for all of them. It means for any of those starting point. You can start from any way. All right, I think everyone should start from that part. Then one mark for the substitution of the work done by gravitational force, substitution of frictional force, substitution for change in kinetic energy, and the final mark is for the final answer. Guys, this is it. Thank you for watching. I hope it helped. If it helped, subscribe for the channel, and I'll see you next time. Mr. G.